Ma'am, you're muted.
So, hello, am I audible? Hello.
Yes, ma'am. Now you're audible.
Yes, ma'am. You are now
Yes, good evening.
audible.
Okay, so let's wait for 5 minutes and then we'll start our class. So today's session is actually based on Solve with us week 7. That means we will solve some of the question related to the limit concept. Okay.
Ma'am,
Yes,
ma'am,
Deepan.
there are some doubts in trigonometry.
In trigonometry. Okay, you
Yes,
can
ma'am.
ask.
Ma'am,
So what's your doubt?
assignment number 7.2 from question number 5. No, ma'am, question number 4 and 5.
Okay, so you have doubt in assignment. 7.5 na?
7.2.
7.2. Okay.
Question number 4 and 5.
So question number 4. So here suppose so sin x plus y formula is given to you. Then they say which of the following is true. So what you have to do, you just have to use this formula to expand sin 2x. So you know sin 2x can be written as sin of x plus x. And then if you expand it, you'll get one of these forms. Okay. Just try to solve it. I don't think it's that difficult. Let me share my screen. This question, question number 4.
Yes, ma'am.
So here sin x plus y formula is given to you and some formula you have to derive. So what you can do, you can just change it to be sin 2x. This is same as sin x plus x. And then you write the formula in terms of sin and cos. So it will be like sin x cos x plus again cos x sin x. So it's equal to 2 times sin of x, sin x cos x, right? So similarly, you can find out the formula for sin 3x. And the same thing you have to do here also. So it's not that tough. Let's try and little bit computation is there. That's all. Fine.
Okay, ma'am.
Ma'am, can I ask my doubt?
Yes, Manish.
7.4 first question, ma'am.
7.4.
First question.
Okay. So here consider the following function where R is a set of real number and a set of natural number. But you have to say which of the following represent a sequence. Okay. So again, you have to consider the definition of sequence. What is the definition of sequence? Can you recall? What is the definition of sequence in terms of function? Manish, are you there?
Yes, ma'am. Like it's a set of digits, right?
Yeah, so one definition is the set of digit and another one is that it's a function from natural number to any other set. So this is another mathematical definition of sequence. So sequence is nothing but a function from from natural number to any set. Any set, you can take here any set.
It's an integer. You at the end of the point you want to say.
No, here you can take anything. You can take integer, you can take rationals, you can take real number. Doesn't matter what your codomain is, but the main thing is your domain should be natural number.
Yeah, ma'am.
That's the reason we can list out our sequence, right? A1, A2, A3, and so. This is nothing but the value of function at 1 and similarly at 2. And since we contain 0, so we start with A0. Now this will be value at x 0. Okay. So now I think you can
Okay, ma'am.
answer.
Yes,
Uh,
ma'am. Yes, ma'am.
Now, just give me 2 minutes. I'll be back.
Hey, hello everyone. So, yeah, this is Vishal. Uh, so in the last some session, I heard that you guys are facing some issues. So can you just elaborate on that? What is the issue that you're facing in Maths 1?
Hi, Vishal. Good evening.
Yeah, good evening. Yeah.
So I raised this issue. Today is this week 6, and the Friday would be the week 7 deadline, right? So it is possible. Actually, it's within 2 days. There is a deadline. It's possible to extend. I was asking. That's it.
No, so the deadline is already fixed for the foundation course.
Okay.
Yeah, so that
Okay.
can't be changed now because we already know that the quiz 2 is also approaching, and second is the quiz 2, and then 22nd will be the final quiz. So we don't have much time. If we'll extend it again, the week 6, 7, 8, let's for example, if I'm extending for week 7, again the week 7 and week 8 will collide, right? So because this videos and all has been released, I guess 2, 3 week back, right? But
Uh,
we have extended because of the quiz, not because of the quiz, because of the festival and all. Some of the dates has been extended for some days, and then now because we have extended for week 6, so week 6 and 7 both are almost on the similar dates, the deadline. So that's what happening, I guess, for all the courses, for all the foundation courses, even though for all the diploma courses also, the same thing is happening. But this time we have made the deadline in such a way, in considering all the festival and all, such that we can't extend the deadline as of now.
it's fine. Actually, that's what she was also saying. It's fine. Yesterday it was clear. Thank you.
Okay, okay. Any
Mm.
other things?
Michelle, Ravi here. Just a question. So, what's the expect? So assume that I'm entering a new week. Okay, maybe it's a very basic question. Apology if it is it's not. So,
No problem. Yeah.
there is a set of around like 4 to 5 hours of video for that week is there, and there is some tutorial and some exercise, right? Combined together, it will be roughly around like 8 to 10 hours of effort which we need to put, right? So before we attend your classes, either TA session or something, right? Because as of now, if you see, I think Friday or Saturday, that is week 8 summary class is there. The issue is like the way we are and the class which it is there, right? There is a huge gap and there is a sinking issue. Maybe it is my issue as well. I'm not saying that it is a entire, all the people are facing this issue. As a advice or like suggestion, how you want us to prepare so that like we are in sync with the class that is being taken. Because as you say, because of some festival or something, there is some gap and we couldn't able to catch with you guys who is taking this session. Maybe some of the people here might have already gone through all the thing. They might have been have some time and stuff like that. So in general, what is the thing which we need to follow so that like we are before you guys can take the session? What is the expectation? We are supposed to complete all the video for that week and then attend that session. That is how it is, or how it will be.
Yeah, so see, for example, for week 8, I guess week 8 has already been released last week, like last Friday, correct? We will be starting our session, so we expect that if you just go through the lectures of the prof, by maybe like you have time till our first session. Our first session for week 8 will happen on Saturday, right? Saturday, that will be the summary. Correct. And then you'll be having Sunday one more session for the doubt, and then Tuesday we'll try to solve some problem. Right. So this is how the schedule has been made. Maybe there is some changes in some of the weeks because of the festival and all, but this was like from the starting we expected. Like if we are releasing the content on the Friday, like the last Friday it has released. So if somebody just go through the lectures, okay, and try to just solve the activity from their side, even though the TA session will keep on happening, we will be taking the first session with the summary, like just briefing all the concept on the Saturday. And and it's not like if somebody just come directly to the Saturday session, it will be very difficult for anyone to go through that. For anyone, like it's not just you or if he hasn't gone through the content at least once, it will be very difficult because there is a for some student maybe for some student they have just came after 12th class 12, so for them there won't be much issue. But somebody who has some gaps in the studies, like he's working or something, so for them like this has been told in the starting to prefer to go through the lectures on the same Saturday, Sunday. Like Friday, if the release we are releasing, so go through the content maybe by maximum by Tuesday. So that on the Saturday, if you are coming for the session, we'll just give you a brief. You can just ask your doubts. And then again, next day, again, you have a whole 2 hours for the doubts itself. And then you'll be having one session. Even though one session has like this time it was cancelled, like, but we are doing the third session also because we have already recorded some of the same set of questions. It's already there on the YouTube. But we even though we are doing it just for so that if we are just doing the third session also it is helping. Even though we have 4 more sessions for the TAs. If somebody has doubt, that's not the compulsory. If somebody is facing like you have gone through the content and then you're solving some problem and then you're getting some doubt. So you have the continuously the session, TA session. There you can go just for the doubts. Okay, if your doubt is not getting resolved, you can join our sessions and then ask your doubts and all. So this is how it has been planned. But as because most of the people uh, not most, like even I when I was a student, we just see the deadlines, and if the deadline is tomorrow, then we start from maybe 1 or 2 days before going through the lecture. So this is how like, and then the problem occurs like week 6 today is the deadline or tomorrow or today is the deadline. If somebody would have started like watching the lecture 1 day or 2 day before, so he'll be in a it will be difficult to go through the log if somebody has a gap of 4 5 years, so it will be difficult to him to catch up. Okay, and then if just finishing the deadline like 6th week and then just have 2 days to go through the limits concept, and limit concept is a bit tedious to understand in 1 or 2 days. So that will be seriously tough for somebody has not gone through the lectures in advance, like when the lectures was released, like 7th week was released I guess two week back. So it was expected that you should have gone through the lecture, but yeah, this is how it has been planned. Anything?
Fine. So Vishal, one more question is like the sessions that has been taken here, right? So there are few TA sessions and some
Yeah,
professors.
so
are
yeah,
taking it.
four TA session happens in a week and 3 instructor, mostly three, some week two, but mostly it has been happening three. Yeah.
Okay.
Correct. So the timing and all also mostly the timing will be seen in the calendar. Mostly it follows the same thing. Today it has been like extra session has been happening because yesterday I felt like okay, maybe some people are is having some issue in solving the problem. Maybe somebody who is working, so they are facing some issues. But what I'm trying to say, so this is just the starting. If we'll just go through the second term or third term, there the courses will be advanced, and then you'll have to catch, like you'll have to start watching the lecture like from that itself, or maybe many people just go through some of like 2 3 weeks of content in advance in the break itself, so that he'll be in a good position to catch up, like because this is like in normal colleges and all you'll be having only 2 semester per year. Here you have 3 semesters, so it is seriously difficult to like go ahead and catch up with, because 1 week you'll be having Friday if you're just missing uh, because you'll be having continuously the content will come, and then you'll have to go through the content. If you're missing some weeks, and each of the weeks the next week as related to the previous one, so if you are just missing out some of the weeks you'll be having facing like you'll face issue in the coming weeks and all. So that's why we have so many sessions. We have arranged it so that in the later, in the next term and coming terms, we'll be having very less sessions also. Like the number of live session will start reducing, because we expect that after learning this many courses and all, we expect that the people will be in the position to handle everything by them.
Okay, Vishal.
Yeah.
Yeah, and
Any
Vikrant,
other issue that you're facing? Yeah. Yeah, go
yeah,
ahead.
and with regard, I think this semester is, I think only in this semester we will have the situation because of the festival time and so on, am I right?
Correct,
Because
correct.
other semester we won't have the issue, if I'm right.
See, that's the third semester. Mostly, it is like a very small semester as
Yeah,
compared to the first two one, like the
Okay.
first and the second one, because it started. It is like a 2.5, almost not even two. Like it's almost 2.5 month itself. But the other semester will go at least 3 or 3.5, something like that. So yeah, so the last semester is mostly it's shorter than compared to the first two. So the people face is issue in this semester. Yeah.
And second thing, this semester also started a bit late, I think, some compared to this thing, if I'm right,
For the
from
last
May.
year, but yeah, this will be the timing for the next year also, the same timing,
Okay, okay.
because you'll be having 1 month of break for the paradox and all, 1 month break or
Sure.
something. So that's why, because earlier what used to happen, the paradox also, the semester was going on, but then the student told to have a break in that time during the events and college, like the event. So that's why we have just put in hold, like earlier it used to be week 3 or 4 during the event and all, but we now, this from this year or last year, I'm not sure, we have kept it for a week of gap for the events, for the preparation of those events and all. So that's why everything got delayed, like from the second term. So first term it will be fine, the second term got delayed for 15 days, but this will be the usual for the next coming years, all like for the upcoming years and all.
Okay, okay.
Yeah, but the
Yeah, I
timing,
do understand. And
because in the starting, yeah,
you
yeah.
also mentioned in the coming semesters, the classes, I mean, the number of live sessions will go down, means obviously those will be new subjects, am I right? So, for example, only for Math 1 and Math 2, if you would think about it, I mean, are you talking about Math 1 and Math 2
Yes.
also, it will be reduced, or your
That's too, it will reduce,
diploma
like for,
thing?
like we are having 7 session altogether, so it will be lesser, maybe 5, because normal in the diploma where we have maths 2 and all, we have 2 instructor session and you'll be having TA session 3, so you'll be having 5. Again, till second year you'll be having keep on continuing the same number of like 2 instructors from some TA 2 3 TA session. Again, when you'll go to the third, like the degree and all, you'll be having 1 per week, so something like that happen. Yeah.
Oh, okay.
Hmm.
I was wondering when you said, because
But
people
like
who are
if you like people, if people want some extras also, we can have some extra session. But mostly it won't be like whatever I feel like people doesn't join if you have to, or like if I'll put extra. So you can see it now also. We have almost 5,000 students, but 33 or 35 have joined now. So this is how it happens for the coming terms and all.
Yeah, that's all. Yeah. Okay, thank you. Because I was wondering, and as you also mentioned, like when we are talking about the deadlines, I think only till we also discussed earlier in one of the earlier session, only till week 8 we will have this issue, and after week 7 we have this issue. I think from week 8 things will become normal, right?
Because week 6 we have extended the deadline. That's why
Yeah.
many of you felt like week 6 and 7 are almost in the same day. Again, if I'll extend the week 7, it will feel like week 7 and 8 again will collapse. So you'll feel like how come it has happening. So that is what. If you would have, we have not have considered the festival and all, week 6 deadline I guess was 1 week back itself. So but we have extended because of the festival, Diwali, Chhat Puja and all those festivals. So we have extended some. So it came almost on the similar day of week 6 and 7.
Right. I do understand. And we
Yeah,
have I mean 8 deadline coming on 20th itself. Okay.
correct. Yeah,
The 45-day gap is there.
yeah.
Fine.
Okay. Anything else? Can we start it now? The sessions and all?
Yeah, nothing. This is what happened yesterday. Who was asking the same query which was raised by people within 2 days. Also, I was asking what he was asking, like the number of sessions will be reduced. So I raised the query to you also. You are reducing this
Yeah,
all
so no,
session.
number of session has not reduced. Yeah, so almost the three sessions was happening. Week 6 we were having 2. Yeah, but maybe all those festival and all because of that. But now from onwards, week 7 we have 3, and then week 8 also will be having 3, 9. So it'll keep on going now.
Yeah.
And I
So
don't know,
this is
Vishal.
what This
Yeah,
is
yeah.
what I asked the last session. So last session, I was asking about the reduced session. So I would like to know about in further weeks it is reduced means will be under struggle. So start with the session is totally going to be reduced. That's what she was saying. And yesterday she was saying that we can't do. I mean, I was asking this question. So she was saying that within this solving session you cannot ask this kind of question. So this session is only for solve with I mean the query session, and you can ask for a discourse or something else. And so it was like went wrong actually yesterday. But my point is totally different, that I was asking only about the my doubt and people doubt only. So that is what I was asking. Nothing went wrong. Even yesterday I was there and I was raising this question. That's it. And I was
Okay.
clear. That's what, if it is possible. And even last time also, if you are requesting, and it could be extend, and that also was possible, right? So, and it's in your hand. So that is what I was, possible or not. Just that's it. I'm not forcing people to have to do that, and because I have to understand the situation. But if it is possible, because week 8 is 20th. This week 8 will be getting. I mean, the graded assignment by 20th will be getting the last date, right? So after 10 days, we have time for the next ninth week, I hope so. In between 10 days, are there, it is possible or not? If it is like possible, it can do that. That's what I was asking.
Yeah, so see, the deadlines and all, it can't be extended for one courses. If it has to be for all the courses. So that's the issue. If I have to like increase the deadline or change the deadline, so that has to be for all the courses like Stats 1 and City and English 1 also. So I'll have to do it
Okay.
for all the courses. Yeah, so that becomes,
Okay.
see, this term it is really difficult, but even though I can just ask for changing the deadline for week 8 you're asking, or week 7. Week 7 is the 15th. Week 7 can't be changed. I most
Yeah.
probably, even though I can ask to
Okay.
the further like
Sir, we have managed, sir. Like I
That is
think
what
most
even
of the people have managed, sir.
that is
Leave it.
manageable. But yeah, Manish, I'm not saying that it
No,
can't
I'm not
manage,
even
right?
arguing. Yeah,
Yeah, yeah,
okay.
yeah.
Okay,
It's
okay.
not a
So
big
I'll just
difficult.
check, but mostly you can just think as 15th only. But I'll check tomorrow or day after. Like tomorrow, I'll check with the team if they are able. Like because most in the starting itself, when the term was starting, it was uh, told everyone like it this term we can't change the deadline because the deadline has been done is like done in like thinking all the stuff like all the like festival and all the things has been kept in the mind, and then only the deadline has been set. So we can't change the deadline. So that is what has been told from the higher authority to us, that you can't change the deadline for this term. So
Got
that,
it. Got it.
but even though I can ask, and then I'll mostly
Yeah.
Thank you. Thank you.
99% not be, but I will further ask. Yeah. Okay.
Even the grading assignment, they were very clear that the data has been fixed based on Diwali and so on. They were very clearly
Correct. Yeah,
with that part.
the grading is grading document itself was mentioned that it can't be changed. It has already all the deadlines has been done, kept in mind, like all the festival and all. Okay. Anything?
Yeah, and one more thing, Vishal. I don't know about the other courses. With regard to Monday, is it going to be a kind of Monday we don't have any session? This thing. So is it the same for all the courses? No session on Monday for anyone?
I don't know about the other courses, but
Because
I
stat
think
we,
it is
stat we don't have a session on Monday. Math also we don't have a session on Monday. So I was thinking like why the Monday is actually left as it
because
is.
most of the courses, the session will be on Saturday or Sunday. So that's why one day of gap. Because I felt like I can't put it on Monday because I have Saturday, Sunday, so I can't put it on Monday. So that's why I put it on Tuesday. If you want, we can put it on Monday also. If you want, like one of the sessions should be shifted. But then again, like I can't. This like we felt like in the starting we have discussed, and then only we came to the conclusion that the weekend would be the best day because many of the people are working professional.
No.
That's
For summary, I mean, don't touch the summary. Weekend is best for the summary. It's the right time for summary session. That's a good play. Even that's also even I asked for other course also. So I'm talking about. I was wondering why Monday is actually vacant. I thought maybe to be a kind of instead of a busy day. I don't know if Wednesday not see it's a very packed sessions are coming,
Okay.
especially
So
even though the
if
deadline is
everybody
there on
is
the day.
fine, I can just
Wednesday
shift
we
the
have quite a
Tuesday.
lot of sessions.
Yeah, Tuesday session can be shifted to the Monday. If you want, I can just reschedule the session, all the session that
No,
is
Something
scheduled on the Tuesday to the Monday.
see, my opinion is Monday you are keeping, na, that is quite beneficial only for me because that graded assignment and all we are working out, no. So then we have the time. Otherwise, we are engaged with the discussions, interactive discussions. Then we don't have the time. So for the regular people, there is no problem. For the working peoples now, and then after attending the that sessions, so they're difficult to continue
Okay.
or work out.
I got it, fine. So yeah, we can change it. There is no issue in that. We can
Yeah,
change it.
no, what I am telling now, Monday, whatever you're keeping empty, it's okay for me. That's why I'm telling. So
No, okay, you
Again,
are
I think you have to
asking Monday to
go
be
for polls.
empty.
yeah, so Monday
Again, you
we
have to
don't
go for
have any
polls, I think.
sessions now. It's good actually. So then we have the time to work out. That's why.
Yeah,
Because
that is
for
what
the
happens. See,
yeah,
some people will say like Monday is fine, some will say Tuesday is fine. So that again difficult for us, like in the starting. So that's why whatever is going on, so we just stick with that. Okay, Saturday, Sunday is fine
yeah.
for professional, and
If
but
people are working for the graded assignment on Monday now, so they will work out and they have any doubts now. It's a time to ask in Tuesday. Then
correct.
yeah, if you are shifting Tuesday to Monday now, then it will be difficult. So better for me, it's very convenient. Keep Monday no sessions. So if you are putting additional sessions, it's okay. But if you are shifting Tuesday to Monday, it's not okay. That's why I'm telling.
Yeah, got your point. Got your point. Yeah. So
I think in this semester, I think it's better not to disturb. I mean, whatever is Monday is fine, we can go with it. And already we had quite a lot of what do you call pushing up and down the last 2 weeks with the
yeah, correct. Because most of them, like most of you would have like now has said that this is the timing for the session. If I'll change it now, it will be again difficult. I'll have to send the announcement like every time. So it's like for this term, we'll be sticking with the same timing and all, whatever has been there in the extra session. Okay, I can put it like whenever you want. Maybe revision session and all, we can put it on Monday if you want. So that's fine. Not revision session can't be like we can't put it on Monday because Sunday you'll be having exams. So before 3-4 days itself, we can take the session. So yeah, so any extra session that will happen, like we can put it on the Monday or something like that. Okay.
I think the revision, the summary, and problem solving is always good that you keep it in the evening, the same time 8 to 10, because as you mentioned, people who are working, they also would like to join and so on. Even if you put the same, that's my opinion, because 8 to 10 seems to be a kind of convenient time to most of the people who are working and non-working people with regard to maths at least. And even for the case of stat, I could see that. So that I think we don't have to disturb that, so let it continue in time.
Hmm. Hmm. Okay, so for the revision session and all, we'll change it like okay. We'll just keep like that schedule that day where there is no sessions, no session for the stats and the CT. I'll take that day. That will be fine, I guess.
Yeah, so because the TA sessions, I think, as you said, the numbers are very thin because it's in the daytime. Many people
So
seldom are able
that
to
we
attend the
can't change.
TA
Like that
session.
we can't change. That is just for if you are having issues facing issue, you can just go join and then that's not like because that will be colliding with the other session also because there are a number like 4 sessions for each. We can't get the time like that is not colliding with the other one. So, yeah.
Yeah, and also I don't know whether I also raised these things. I joined. I don't join on a regular basis, but I find whenever I try to join in some of the session, I felt those sessions were cancelled without any prior intimation. So I was scheduling the whole time for the TA thing only to find it was not happening on the day. So I also raised this in one of the session. I don't know with whom I discussed about that, and I requested them to discuss with the team to.
The session that I get to know, I guess it has just cancelled once or twice because
No,
I guess
almost 4 times if I'm right this semester if I'm right.
4 times. Okay.
I don't
Like,
know the right number. Maybe
mhm.
you can actually talk to the person who the TA when they this thing. So just I want to. I mean, as I told you, I'm not a regular person who attends all the TA session. But when I felt even last week or something when I was there, I think many people came and they also visited and they also left. I think it was in the afternoon session on a Saturday and Sunday.
Okay, I'll check. But as far I know, 2 times it has been cancelled. One time it like because he was sick or something has happened. But he told me later. Otherwise, I would have cancelled it and sent the announcement. But I came to know later. And the one time, I guess, I don't remember, but 3, 4 like week back he missed or something happened. So twice I can know, twice it has happened. But if it has more than that, I'll just check with the team. Like
Yeah, and again, the TA session, so there in the weekend is more crucial compared to the weekdays for me at least, because as he mentioned, for working people that's more good and so on, even for non-working people also who are going to college. So even if the weekday session is moved here and there, that's not an issue. But weekend, I think one Saturday and one Sunday it was cancelled if I'm right in both the cases. So that is kind of we don't know. I think that please take care at least that is not cancelled. Even if it is cancelled, kindly let us know in advance so that we can schedule the day accordingly.
yeah, good. Yeah, correct. Okay, I'll check. And but from
We
now
need to
onwards,
balance
there
with
won't
a
be
lot
any
of things.
session that will be cancelled without informing you guys. That I can tell you. Yeah.
Thank you.
Okay.
Thank you so much.
Okay. Thanks. So
Thanks,
anything?
Vishal, for the input. Yeah, thanks a lot.
Okay. Thanks everyone. So we'll just start with the session. Yeah, Samiksha, can we start?
Yes, sir, I'll start.
Thank you.
Okay, so let's try to solve some question. But before that, let's recall some of the facts about the limit of a sequence or limit of any function. So let's start with the definition of sequence. What is a sequence? So sequence, informally, if you want to say, then it's nothing but a list of numbers. Okay, so any list, you can think about that list to be as a sequence. But formally, mathematically, a sequence is nothing but a function from the set of natural number to any set. So this is the formal definition of sequence, that any function from the set of natural number to any set defines a sequence. Why it defines a sequence? Because if you have a function f from natural number to any sets, here the set can be anything, real number, rational number, integers. Okay, so then using this function, you can actually extract one list, and that list will be containing the image point. Image point means the value at the function value at 0, comma the function value at 1, comma the function value at 2, and so on, right? And this particular function values are also known to be the term of sequence, and they denoted by a script 0, a1, a2, and so on. So that's why we sometimes denote sequence just via listing the element. Sometimes we define sequence via the nth term expression, right? If you have a sequence an is equals to -1 to the power n, then you can easily understand what is this sequence is actually. So this is the nth term of the sequence. So using this formula, you can compute the first, second, third, fourth, and so many terms of the sequence. And the another representation of sequence is by giving some relation between an and an plus 1, right? That is recursion relation. So suppose I'll give some relation between an and an plus 1 in this fashion. So suppose an plus 1 is nothing but twice of an, and I fix one a naught to be equal to 3, right? So now using this information also, you can extract one sequence, and this is known to be the recursion relation between the sequence. So this all things have been covered in the theory part. Now let's recall some of the facts quickly, and then we go to the we will solve some of the questions related to the sequence. So here the main point is these facts, these theorem. So what does this theorem says? It says that if we have a sequence A and B, and that sequence is converging to A and sequence Bn is converging to B, then with the help of these two sequences, we can actually evaluate so many sequences. If other sequences are defined in the some arithmetic relation is there between an and bn, that means an plus bn or an minus bn and so. So it says that, so suppose an is a sequence and en is converging to a, bn is a sequence and bn is converging to b, and these are your hypothesis condition, and this thing first you assume and then conclude something. Because I think we saw some example where an plus bn actually converges, but neither an nor bn converges, right? So I think we already see this question. So the question was, suppose an plus bn converges, then does AN converge? So this is one question. And another one will be, does BN converge? This is another question. So we observe that it is not possible. The answer is no. Because you can simply take two sequences, AN and BN, in this fashion. So suppose AN is 1, -1, 1, -1, and so on. And BN is equals to -1, 1, -1, 1, and so on. So if you compute the AN plus BN sequence, it's nothing but the whole constant 0 sequence. And this is a convergent sequence, but here neither AN nor BN converges. So that's why this hypothesis condition is somewhat important to us. So if AN and BN converges, then only we can conclude this these all points. Okay. So the first point says that if AN converges to A, BN converges to B, then the summation of AN plus BN converges to A plus B. The second one says that the constant multiple will converges to C times A. Same with the subtraction, same for the multiplication. And using this, we know that a polynomial is nothing but combination of all these operations, right? So if you have a polynomial in X, it's nothing but simply, let's take it to be something else in place of A. So a polynomial is nothing but, suppose you have some point, coefficient will be there. So coefficient, let's take C naught x to the C naught Cn x to the power n plus Cn plus 1 x to the power n minus 1 plus and so on plus C1x plus C, right? So polynomial is nothing but the combination of all these operations. So if the convergence of a sequence some kind of obeying these operations, then if we have a polynomial, then the polynomial of that particular sequence, that means P of an or F of an, will always converges to F of a. Similarly, we can say for the division also, but in division we always have to take care that B should not be equal to 0. Because if B is equals to 0, then A by B does not make any sense, right? So that's why if B is not equals to 0, then AN by BN is also converges to A by B. And similarly, for the exponential function, A to the power X function also, C to the power AN converges to C to the power A for any real number C, where C to the power N is a real number for all natural number. And same for the logarithmic function also. And this is the last one, is known to be the sandwich property of a sequence. So let's try to understand what is this. So the sandwich theorem says that if you have three sequences and the one sequence is getting clustered between two sequences, then that sequence also converges to the same. So that means suppose you have two sequences, AN and BN, AN, BN, and CN. Suppose we have three sequences, AN, BN, and CN. And here what is happening, the term CN get stuck between AN and BN. Okay, so that means AN is less than equal to CN is less than equal to B. And here, if these two terms, these two sequences, AN, BN, converges to a one fixed quantity, so suppose AN, BN converges to L, then they actually force to this particular sequence that it should be converges to L itself. So this is also known to be the sandwich property. So what we are doing, we are some kind of sandwiching this CN sequence in between AN and B. So if AN converges to A and BN converges, AN converges to limit L and BN converges to limit L, then this condition implies that the limit of sequence CN is also equal to, right? So some kind of, we are sandwiching the term of sequence CN in between AN and BN, and then forcing, because of the same limit, we can actually force the sequence CN to converge at the limit. Okay, so these are the basic rules for finding out the limit of a sequence if it is made by two sequences whose limit is already known to us. Okay, so now we will solve some of the questions related to this particular topic only. So let's try to solve the first question. So again, I'll give you guys, since there are 4 different sequences, so let's take 4 minutes or 5 minutes to solve it. Okay, and please answer in the chat box so that it will be helpful for others also. Okay, so let's take 5 minutes to solve it. It's 8:42 to 8:47. And at least try to solve it. It doesn't matter that you will get correct answer only. I mean, whatever you get, think about it and then answer in the chat.
Ma'am, could I ask a doubt?
Yeah, sure.
Ma'am, before you have explained about we can create a sequence. You have created a sequence that a naught equal to 3, and could you once again explain what was that? Like, could you give a proper, neatly example?
Means which recursion relation? You're asking for recursion?
Yes, ma'am.
Yeah. So actually, what happened? We can actually we can give a description for sequence using the relation between an and minus 1 or an plus 1. So what I say is that if I consider a sequence with this relation, that an plus 1 is equals to twice of an, and with a fixed quantity for a naught, because I have to start at some point, right? Here a naught is unknown to us, but if I give some fixed quantity to a naught, so let's take a naught to be 3, then using this information, we can construct a sequence. How? So the first term of sequence is a naught, which is equals to 3. Now, what is this? What will be the second term? That will be a1. And a1 is nothing but if here in place of n, if you put 0, then you'll get that a1 is nothing but twice of a0. So that means it's nothing but twice of a0, which is twice of 3, that means 6. Similarly, you can calculate a2. So a2 is twice of a1, so that means 12, and so on. So in this fashion, you can actually construct a sequence. Is that fine?
Yes, ma'am. Understood.
So, ma'am, if you say convergence, right? So, with an example, like, can you please explain that what is that exact convergence thing is, ma'am?
Convergence of this sequence?
Yeah, yes, ma'am.
So see, I think the sequence is not convergent because you can observe that the value of term is actually rapidly growing, and if you change the representation of this sequence, so this is nothing but an plus 1 is nothing but 2 to the power. So we can actually construct a different representation of nth term. So nth term is nothing but 2 to the power n times 3. Because here what is happening? A naught is 3 into 2 to the power 0. A1 is 2 to the power 1 into 3. A2 is actually 2 square into 3. So this is the nth term representation for this sequence. An is equals to 2 to the power n into 3. And we know that as n approaches to infinity, this term 2 to the power n will also approach to infinity, right? So that means the limit of sequence here, limit of an is nothing but infinity. So that means it's a divergent sequence, not convergent. Right?
Okay, okay, okay.
Ma'am, after the factorizing, we have to submit to equal to -8, right? This first one. So all the thing we have to equate it.
Yeah, I mean, by finding value, you have to equate it over the right hand
Mhm.
side and then choose the correct option, I think. You're asking about the question. No?
Yeah, yeah.
So you have to first find the value and then see that it is equating to the right hand side or not. If it
Okay,
is,
okay, okay. We're checking it.
yeah,
Okay.
some kind of we have to check. Then only this statement holds, right? The statement
It is
says
after
left hand side equal to.
factorizing. After factorizing, substitute the x value into the x, right?
It's the same thing.
Correct. Thank you.
That's it. Okay, so I got only one answer. If you guys get your answer, then please enter in the chat box. Time is over, but let's go up to 8:50.
Ma'am, regarding sequences, you have said when an belongs to, like, it converges to A and Bn converges to B, if we add, they both will converge to what was that, ma'am? You said it was wrong, like while explaining that. No, if a plus b belongs to one limit, it need not be required. Yeah, that one important statement you have written. Hypothesis.
So what
That
I
one.
was saying that if you if you
last option
lose
question,
this
please.
assumption, yeah.
Question.
So if you lose that condition, that means the assumption. So the statement, suppose an converges to a and bn converges to b. If you lose this condition, then you cannot actually imply that an plus bn will converges to a plus b. So I was telling that it is important to say that an plus bn converges to a plus b to have this two limits. And it's only possible in this particular way. So that means if you know an converges to a, bn converges to b, then only you can imply an plus bn converges to a plus b. But actually you cannot go in this direction. This is not true. This direction does not work. For that, I have taken the example that 1 minus 1.
Okay, ma'am. Like vice versa is not true.
Vice versa is not true. Only one direction is true.
Understood. Thank you.
You guys cover up to continuity of function, right? I mean, in theory part. So,
Continuity in 8th week, right?
continuity is in 8th week. Then limit of function is done, right?
Yeah. Continuity in 8th week.
Okay. Yeah, continuity, it's easy if you know the limit. Then so let's try to, yes, Aditya.
And how much marks weightage is for week 7 for quiz 2?
Marks weightage, I cannot tell right now, but before the quiz, I'll give you some pattern that what will be the weightage for each week. For now, I'm not sure, but yeah, there will be questions from week 7.
Ma'am, from week 1 to week 4?
Week 1 to week 4, there will be very less question. 1 or 2 you can assume. Okay, so let's try to solve this question. So I have some answers here. So in the first option, if you observe, so then in the first option, if you factor out this particular quadratic polynomial over the numerator and denominator, we get these two factors, right? So here what is happening? We want multiplication to be -7 and the addition to be -6. So the choices are simply 1 and -7, right? Because if we multiply, we'll get -7. If we add, we'll get -6. So because of this reason, we factor out into x plus 1 and x minus 7. Why we are factoring out? Because if you substitute x is equals to -1 in the denominator part, what you will get? You will get 1 minus 3 plus 2, which is equal to 0. So that's the thing mentioned here, that if the given function is of the form rational form f of x by g of x, and g of x goes to 0 as x goes to a, so in this case, what we have to do, we try to factor out x minus a from the numerator and the denominator and cancel it out, and after that we will apply the limit. So this is actually related to rational function. I'm not sure you guys are since you guys are not familiar with continuity. So what happens if we have a rational function or rational limit? So that means if we have limit some x going to some point x naught, where f of x, in place of f of x, I am writing p of x, because here we have polynomials p of x upon q of x. So what happens? So this limit is actually equal to P of x naught upon Q of x naught. If the denominator is not becoming 0. So if Q of x naught is not equals to 0. Okay, so this is the result. You can say that if we have a limit where x going to x naught, P of x upon Q of x, where Px and Qx are polynomial, and Q of x naught is not becoming 0 at Q is not becoming 0 at point x naught, then this limit is actually equal to P of x naught upon Q of x naught. Why this happen? Because see, polynomials is nothing but a function combined with the operation addition, multiplication, and taking the power of variable. And we know that these all operation some kind of follow the convergence of sequence rule. So that means this limit x going to x naught P of x is same as P of x naught, and limit x going to x naught Q of x is same as Q of x naught. So we can distribute the limit only if Q of x naught is not equals to 0. So this is the result we want to apply here. But in the first option, what is happening is x goes to 1, this denominator is becoming 0. So that's why first we will try to factor it out and try to cancel out this x plus 1 term. Is it possible or not? In some cases it will be possible, in some cases it is not. So here what is happening, there is one common factor of x plus 1 in the numerator and denominator. So we'll just cancel it out and we'll get x minus 7 upon x plus 2. Now again, this is in the form of px upon qx, right? Limit x going to x naught, px upon qx. So here x naught is minus 1, px is x minus 7, and the qx is x plus 2. But here what is happening? Q at x naught is not equals to 0. So here if you put minus 1, so Q of minus 1 is minus 1 plus 2, which is equal to 1, not equals to 0. So thus we can apply our result and say that this limit is nothing but P of x naught upon Q of x naught. That means minus 1 minus 7 upon minus 1 plus 2. So in the numerator we will get minus 8 and upon 1, which is equal to minus 8. So that's why this option number 1 is correct. Is there any doubt in first option? Anything which is not
Ma'am,
clear?
can't we use L hospital rule?
L hospital rule also you can use. Yeah, that's also correct. Because here both functions are, you can use L hospital. There's no. But for that, you should know the differentiation. So that's why you haven't covered the derivative of function till now. Okay, so now let's go to the second question. Second question is also of the same, second option is also of the same form. So let's see where the, Q of x naught is vanishing or not. So here, this is your Q of x. So here, if you put x is equals to 0, 0, then Q of 0 is nothing but 0 plus 0 plus 2, which is not equal to 0. So that means here you can directly compute the limit by just substituting the values. Okay. So if you substitute the value x is equals to 0, what we get? So in the numerator part, we will get minus 7. In the denominator part, we will get 2. So the limit is minus 7 by 2. Minus 7 by 2, not equal to 8. So that's why this option is not correct. Now go to the third question. So third question says that find the limit of a polynomial. And we know that polynomial's limit is nothing but at that particular point. So this is the another result you can see. So we know that as limit x going to x naught, the function x goes to x naught, right? And limit x going to x naught, the constant function c, this limit will be c. So if you combine all these things, and moreover that limit x going to x naught of x to the power n is nothing but x naught to the. So if you combine all these three results, you can immediately say that limit of a polynomial is nothing but p of x is nothing but p of x. So we are using this particular result here. So this is a polynomial. So what we have to do, we just have to substitute in place of x is equals to 2. So if we do that, this is nothing but 2q plus 4 into 2 square minus 6 into 2 minus 7. Correct. So just I have to calculate. So it's 8 and 16 minus 12 minus 7. So what will be it? It is equal to 5, I think, right? Yeah. 19, so 5. So that's why this option is correct. And the third option, in the third option also, here q of x is vanishing at x is equals to 3. If we put x is equals to 3, it will become 0. So what we have to do, again, we try to factor out the numerator and denominator, try to cancel out x minus 3. And if we factor it out, this x square minus 6x plus 9, so it's nothing but x minus 3 the whole square. And we cancel it out, we'll just get one polynomial. So the limit is nothing but 0, which is not equal to 1. So that's why this option is not. Okay. Is there any doubt in this particular question? Any comments?
No, it's fine.
Okay. Let's go to the second question. Is the question is clear to you guys? Should I show you? Okay, so this is the question. Here also you have to judge the limit, but again, tangent at a point. Have you guys learned about the tangent? Unique tangent.
Yes,
Yes.
ma'am.
Yes, ma'am.
So I think it is. So let's take 2 to 3 minutes to solve this question. Up to 9-3. Just observe the graph, how if you approach to a point from the left hand side and right hand side, where the value of function is going.
The word monotonically means what?
Monotonically means, yeah, it's nothing, just a word for saying the nature of increasing and decreasing. You can just assume increasing. Increasing,
Okay.
monotonically increasing, both are same.
Strictly.
No, not strictly. It's just increasing to equal.
Okay.
I mean, there won't be
Monotony is a
any
word
decreasing,
for.
am I right? There won't be any increasing decay. It will be only increasing. Am I right?
Monotonically increasing means simply increasing function.
Mhm.
Just another word to say increasing function. Because this increasing,
can be-
decreasing nature is said to be monotonic nature of functions.
There can be equivalent point also. I mean, same point
There
also.
can be equivalent point also. It's
Mhm.
not
Got it,
strictly
got it.
increasing.
Strictly increasing. Yeah.
Okay, so let's solve this question. I think it's This question is just by observing the graph you can answer. So whenever you have a graph and since the option involves about limit, so let's recall how we check the limit of a function using a graph. So what happened? Suppose this is your point x is equals to x0, and you have to check if some graph is given to you that limit x going to x0 exists or not. So here we use the concept of left hand limit and right hand limit. So we want left hand limit to be equal to right hand limit. Then only we will say that limit x going to x0 of that particular function f of x exists. Right. So for that, what we do, we'll approach the point x is equals to x0 from the left hand side and observe where our graph is going, right? Where our graph is approaching. So here we want to calculate limit of function at x goes to 0. So this is our point. So here you observe if you approach 0 from your left hand side, then this graph is actually approaching to 0 itself because we are going to approach 0 itself, right? So that means the left hand limit at x is equals to 0 is nothing but 0. So from this part, what we get left hand limit at 0 is equals to 0. And similarly, if you approach the point 0 from the right hand side, here also the graph is approaching to 0, right? So here also the right hand limit at x is equals to 0 is same as 0. So here left hand limit and right hand limit are same. So that's why we conclude that limit x going to 0 is nothing but 0 itself. Okay, so that's why the first option is incorrect because it says that limit of a function is x tends to 0 is 1. Second option is correct because it says limit of function is x tends to 0 is 0. And that's what we conclude from the graph. Now the third option says that limit of the function as x tends to 0 is undefined. So when a limit is undefined, undefined means either left hand limit is not equal to right hand limit, or the limit is being infinity or growing toward plus infinity or minus infinity. So here none of the scenario is happening. So that's also this option is incorrect. Now let's go to fourth option. So fourth option says that there is a unique tangent at a point x is equals to pi, but not at a point x is equals to minus pi. So a tangent is roughly you can understand by a line which touches a graph exactly at one point. So here if you observe the point x is equals to pi and x is equals to minus pi. So this is x is equals to minus pi, this is x is equals to pi. So it is quite clear that here the x-axis is working as a tangent for this particular these 2 points, right? So that means that x is equals to pi also and x is equals to minus pi also we are having unique tangent. So that's why this option is not correct because it says that there is a unique tangent at point x is equals to pi but not at x is equals to minus pi. So this option again got discarded. Now because of the previous discussion, this is correct because we have unique tangent at pi and minus pi. The given function is monotonically increasing in the interval minus 0.5 pi to 0.5 pi. Now, monotonic is just a word to say that particular nature. So monotonically increasing means simply increasing function. So here, if you observe the graph from minus pi to minus 0.5 to pi, so it's not an increasing graph, right? So here first it's decreasing up to 0 and then again increasing. So by the observation of graph, clearly it's not monotonically increasing function. So that's why this option is not correct. The last option says the given function is monotonically decreasing. And monotonically decreasing means only decreasing. Okay, so this option is also not correct because first the function is decreasing up to 0 and then increasing, right? First decreasing to 0 and then increasing to 0.5. So that's why both of the options are incorrect. Okay. I hope this question is fine. If you guys have any doubt, you can ask. Now let's go to the next question.
Option 5, ma'am, in above question, ma'am, option 4 is correct in practice assignment. Option 5 is given wrong.
Option 4 is correct in practice assignment.
Yes, ma'am. Ma'am, 5 is given wrong.
Okay, I'll check and update it. There will be some. As the graph is saying, I mean, this is a particular question.
Yes, ma'am. Same conclusion.
Yes. Okay, so then I'll check and update it. Thank you.
Ma'am, I can't understand why this is, how to identify that this is unique tangent or not.
Unique tangent means you want to find a line which touches the graph. Actually, this question you can answer precisely by using the definition of differentiability. But anyway, the tangent means should be able to draw a line which touches the graph exactly at one point. But this uniqueness actually we can answer using the derivative. So what happens if the derivative, if the function is differentiable, there we have unique tangent. But since you guys are not familiar with differentiability, so that's why I haven't used it. I just say the tangent is nothing but a line which touches the graph exactly at one point. So here there is no what you can say corner or
Using
something.
differentiability because I am familiar with differentiability also.
So what happens if a function is differentiable at some point, then there exists a unique tangent. So that's the rule. And the equation of tangent also we can find out. So by that you observe that it's a smooth function over x is equals to pi, correct? Smoothly it's turning. So it's nothing, some kind of parabola type of behavior is here. So we know that parabolas are differentiable. Similar with pi also. Here also some parabola or some x to the even power type of behavior is there. So that's why this is a differentiable function. And whenever we have differentiable function at particular point, there always exists a unique tangent. And we can actually explicitly calculate what will be the equation of tangent at that particular. Okay, so that's the reason for uniqueness.
Okay, so the function, if it can be differentiable, so it has a unique
A
tangent.
unique tangent, correct.
Okay.
Okay, fine. Let's go to this question. So here you have to apply all the previous result. That means you just have to make all this limit in terms of the known limit. These are the known limits for you. Right. So you have to use these three limits to answer the questions. Okay. So I'll give you guys 5 minutes to solve it. You just have to decompose this particular function in your known function and then apply the limit. That's all. So let's set a time for 9:15. This is an MSQ, not an MCQ. Okay. There will be more than one option can be. Okay, so let's try to solve it. So what you have to do, you just have to decompose your limits into some of the known limits. So here the limits are known to us, that limit x going to 0 sin x upon x is equals to 1. Limit x going to 0 log of 1 plus x upon x is equals to 1, and limit x going to 0 e to the power x minus 1 upon x is equals to 1. Okay, now we will use these three limits to compute the other limits. So here what is given to us? So it's given that log of 1 plus x upon sin x, right? So we have given sin x upon x, this limit is given to us, and log of 1 plus x upon x limit is given to us. So what we do, we will change this function log of 1 plus x upon sin x. We'll just multiply and divide by x. So it is log of 1 plus x into x upon sin x into x. Now this x will keep with the log 1 plus x, and this x will take into the numerator and form it sin x upon x. So this is same as log of 1 plus x upon x, and the whole upon sin x upon x. Right, and here we can apply the limit. So as x goes to 0, here also 0 is mentioned. So as x goes to 0, this limit will become 1. And here also as x goes to 0, this limit will become 1. So the answer will be 1 by 1, which is 1, which is not equals to 2. Right. So that's why this option is not correct. Fine. The second option is also not correct because just we calculated the limit will be equal to 1. So it's not an undefined limit. It is equal to 1. So both are the options are in. I am sorry. Because of this 2, it will be equal to 2. So this option is correct. I missed this 2. Sorry. Yeah, this option is correct. So that's why it will be 2 into 1. So that means 2. Correct. Okay. Now the third option says limit x going to 0 sine of 3x upon x. But we only know sine of x upon x. So what we do for adjusting this 3, we can use some tricks. So we know that sine of 3x upon 3x we can do and multiply and divide by 3. Right. Now since as x goes to 0, 3x also goes to 0. So this limit is same as, so that means limit x going to 0 sine of 3x upon 3x into 3. This limit is same as limit 3x going to 0 sine of 3x upon 3x into 3. And now this 3x again replaced by another variable to get this form, limit x going to 0. So this is same as limit t going to 0. Here t is equal to 3x and sine of t by t into 3. And we know that this limit is equals to 1. So the limit will be 1 into 3, which is equal to 3. And this is equal to 1. So that's why this option is incorrect. So not equal to 3. This is equal to 3. So fourth option is correct. So third option is incorrect. Now similarly, as we get that limit x going to 0 sine of 3x by x is equals to 3, we can easily compute that this limit will be equal to 5, not 1 by 5. Okay, so that's why this option is also incorrect. Now we have 4 options related to one particular limit. So let's try to calculate what will be that. Okay. You also have to take care of the x going to 0 or 3x is going to 0 or something else is going to 0. Okay. If all those match, then we can use our known limit. So here it's written that e to the power x by 5 minus 1 upon sine of 5x. So e to the power x by 5 minus 1 upon sine of 5x. We know that e to the power x minus 1 upon x. So here I want x by 5. So I'll multiply and divide by x by 5. Right. So this is same as e to the power x by 5 minus 1 upon x by 5. I'll take this particular factor common. And what is remaining here? Remaining here is x upon sine 5x 5 times sine 5x. Okay. So now this is same as this factor here as it is. Here also we have sine 5x, right? So I want sine 5x by 5x. So for that, what we can do, this will be 1, this is 5. Sine 5x by x, I can make it first. And then this is same as this factor as it is. And it will be, since I want 5 here, so I'll multiply and divide in the numerator itself. It will become 1 upon 5 multiplied by 5 sine 5x by 5x. Okay, now we can apply the limit. So now this limit will become 1 as by the same reason, and this is equal to 1 by 20. So that's why the 6th option is incorrect, 7th is also incorrect, 8th is correct, 1 by 25, 9th is also incorrect. Okay. Is that fine? Any doubt?
Ma'am, can you please explain it again?
Which limit?
E raised to x by 5.
Okay, yeah. So e raised to x by 5, what we know e to the power x minus 1 upon x, right? So we want this form. So for this form, what we did, first we multiplied by x by 5 and x by 5 in the numerator and denominator, because I want x by 5 here. So then I'll just, what you can say, distribute these two things over the non-quantity. I mean, e to the power x by 5 minus 1 upon x by 5. I'll take this factor as it is and write down the remaining term. So remaining term is x by 5 upon sine 5x. So this also you can write in this form, that x by 5 sine 5x, right? But we know sine x upon x is equals to. So here's 5x is there. So I have to maintain this 5x upon 5x. So for that, first what I did, I'll take this numerator x in the denominator of sine 5x. So that means it's same as 1 upon 5 times sine 5x by x. Now here I want 5. So for that, I multiply and divide by 5, because then only the term will maintain same, right? So we can multiply and divide by some constant, then the limit will be same. So if I multiply and divide, so here we attain our required form sine 5x by 5x, and this limit will become 1. And since there is 1 5 here, and I also multiplied by one another 5, so it will become 25. So that's why it's 1 by 25. Okay, is that fine?
Okay, ma'am.
Okay. So should I slow my speed? If you don't understand this, now you see the calculation, just sit down and try to do it by yourself. That will be much more clear what we actually did here. Okay. Now let's go to the next question. So the next question is also of the similar type. So here some limit is given to you and some long function is given to you, and you have to check the limit of this function using the given limits. Okay. So here one thing I want to break, that here limit n goes to infinity is given to you. And in these two limit x going to 0 is given to you. So first what you do, first convert this x going to 0 to x going to infinity, and then try to figure out what will be the form. Okay, so that's your hint. I'll give you a little, let's take it to be 10 minutes at least, because it's a lengthy question. So try to solve it up to 9:35. Okay. So the first hint was just convert these x going to 0, x going to 0, these limits into either x going to infinity, or try to figure out here what you can do to convert to, to use these two limits. Use this. Okay. And this is e, and then this function is different. Okay, I mean it is e, and then the nth root of n factorial, and the c and n factorial are different. Don't confuse that it is e to the power n and then under the root of n factorial. It's some kind of this term under the root of n factorial. This is this a new question or you guys already solved in some practice or activity assignment? Have you guys already seen this question somewhere?
I think this question is in graded assignment.
But
Graded
not yet
assignment
solved,
of-
ma'am.
I have solved it.
Oh, is this a question of graded assignment of week 7?
Yes,
Not
ma'am.
exactly, the value will be different.
A little bit
Little
values are
different.
different.
Yeah.
Yeah.
Um, because that's why you guys answer so fast. Yes. I mean, it's not that difficult, but it's little bit calculated. You have to do adjustment to solve it.
Ma'am, could you discuss?
Yeah, let's discuss this question. So here you just have to do some adjustment so that you will get the same limit. And first thing is, since the ask limit is in form of n goes to infinity, and here two limits are given in form of x goes to 0. So first we convert these limits in form of n goes to infinity, and then we can apply. So what I mean that you just have to observe that this thing that as x goes to 0, this 1 by x will go to infinity, right? So if you use these two relation, what will happen? So this limit will change into limit x goes to infinity log of 1 plus 1 by x upon 1 by x, right? So that's how limit changes as we as if we want to change into x goes to infinity into x goes to minus infinity. Sorry, as x goes to 0 to x goes to infinity. So here is the solution. So I'll just go through it, because if I try to write it down, it will become a mess, right? So first thing is what we did. So we have 4 limits. Here are the 4 limits, and we want to use them. So first we try to achieve these forms, whatever form is written over here. So that means log of 1 plus x upon x, e to the power x minus 1 upon x. All these form we try to achieve and then apply the limit. So the first step is achieving the first form here. So here log of 1 plus 6 by n is written, and we want log of 1 plus 6 by n by 6 by n, right? That's the thing, 1 plus x by x. So for that, what we do, we'll multiply and divide by 6 by n. So if you divide by 6 by n, this factor will be here, and multiply by 6 by n, so 6 by n will be here. Now in the second part here e to the power 1 by n minus 1 is given to us, and the required form is e to the power x minus 1 upon x. So here also we convert it into e to the power 1 by n minus 1 upon 1 by n. So again we will multiply and divide by 1 by n. So here we multiplied and divide by 1 by n. In the denominator factor you observe, so here one factor is here, so which is this one. This is under the root of 2 pi. In place of x we have n. So 2 pi n to the whole power 1 by n is here. But the two things are missing. One is this x, and another one is this x factorial to the power 1 by x. So we multiply and divide by these two things. That means n and n factorial to the power 1 by n. So n is taken here from the multiplication. So 1 by n will be remain. And here n factorial to the power 1 by n taken in the denominator. So n factorial to the power 1 by n will remain here. Okay. So that's how we come from one step ahead. Now we try to again, now we will multiply by this particular function n factorial to the power 1 by n in these two terms. Okay, so if you multiply here, then what happens? So if you multiply this n factorial to the power 1 by n in this factor, so here it will come and n factorial to the power 1 by n. But this thing we can take it into denominator, right? So that means here n is there. So we can take n upon under the root of n factorial, nth root of n factorial, because we have this particular limit. This particular limit we have, which just says that x by under the root of, x root of x factorial. So what we did, we just multiply it by, we just take this this factor inside our bracket and take it into the denominator. So it will become n upon nth root of n factorial. Okay. Now this particular term, nth root of n factorial, also get multiplied by this because of this minus over here also. So here, if you multiply it, it will become in the numerator part nth root of n factorial, and because of this n, we have this n here. And in the denominator, if you observe, then we have the same term here also. That means nth root of n factorial, and this n is remaining. So that's why we get the same term in the numerator and denominator. So thus we can cancel it out, right? So here we have our required form. Now what we have to do, we just have to observe that if we take x is equals to 1 by n, then as n goes to infinity, x goes to 0. So we just have to make these changes. So in place of 1 by n, wherever we see 1 by n, we replace it by x. So that means this limit n goes to infinity will become x goes to 0. Log of 1 plus 6 by n will become log of 1 plus 6x, and 6 by n will become 6 times x. Because here we are assuming 1 by n is equals to x. Why we are doing that? Because the limit are given in form of x goes to 0. but we want it to be n goes to infinity form. So we want to convert n goes to infinity form into x goes to 0. Okay, so that's why I use one substitution here. Now here also we have the same, but in the fourth limit we have x goes to infinity, so we won't change it. We'll let this thing as it is. So it will become 6 upon limit n goes to infinity n upon nth root of n factorial, right? Because 6 is a constant, so whatever limit we'll apply, it doesn't matter. It will remain as 6 only. So only limit will get applicable over this term, which is limit n goes to infinity n upon nth root of n factorial. Now let's come to this particular guy. So here also we have 1 by n. So, and we know the limit is in the form of x goes to 0. So here also we use our substitution that x is equals to 1 by n and change our limit from n goes to infinity to x goes to 0. Okay, so it will become x goes to 0, e to the power, since 1 by n is there, so it will become e to the power x, and minus 1 will become minus 1 upon x. Okay, so because 1 by n is there, so it will become x. So this limit we have evaluated. I mean, we can evaluate it by a given form. Now in the numerator, we have the required form here also, n in the multiplication and under the root of 2n pi upon n factorial to the power 1 by n, which is same as this limit. Okay, so I'll just append limit here and multiply it by 1 because these two terms get cancelled out. I'll just calculate the limit. So this limit will become 1. So it will become e multiplied by 1 into this is 6 as it is. This limit will become e. So 6 by e minus of this upper limit will become 1 and the lower limit will become e, right? So this is 1 by e is here. So this 1 is only in multiplication because of this one, right? So what we get at the end, we'll get e, and this will be 6 by e minus 1 by e, right? And if you solve it, it will become 5 because e and e get cancel out. 6 minus 1 will become 5. So this is the explanation of this particular question. Any step which you guys don't understand or seems to be?
Ma'am, out of this question, in the starting you have said to convert it to extending to infinity. So what I've done for log of 1 plus x by x, I've done L hospital and substituted infinity, ma'am.
Oh, so you have did L hospital rule. So I think
Yes,
you can do L hospital rule. You can
Then
do
I'm
L hospital rule because
then I'm getting 0
infinity
as
by
the value.
infinity.
Is it right, ma'am?
You are getting 0 as the value. I don't think so. Because see, if you do L hospital, so that means for this, what L hospital rule you apply over where? Here? Here? Limit n goes to infinity. This is log of 1 plus 1 by n upon 1 by n. You applied L hospital rule?
No, ma'am. No, ma'am. For x is equal to 0, I applied L hospital, then I substituted the limit. Yeah, I've done 1 by 1 plus x. Then I did it to infinity. Then I get 1 by infinity. So I'll be getting infinity, right? Sorry, 0.
No, now you don't have to further decompose it. It will become limit x goes to 0, 1 upon 1 plus x. Because of this one, the limit will become 1. Here again, you don't have to apply. I mean, you apply L hospital rule twice or only once. Because if you apply once, then we reach up to this form, 1 upon 1 plus x, and in the denominator, we'll get 1. Correct. Now, you cannot apply again L hospital rule because it says that you can apply only if you have 0 by 0 form and infinity by infinity. So here you cannot apply again. So it's just a polynomial, right?
Till there I have applied there. And then I did, what did I do is, I substituted x is equal to infinity.
No, that's the, you don't have to substitute because here x going to 0 is there. So you just have to substitute x goes to 0.
Oh, okay, ma'am. Okay.
Any other doubt over this particular question?
Ma'am, I'm having a doubt in the limit only. The last limit or like the general limit. Limit extends to infinity x by root over x factorial in the power of x. Yes, ma'am. If it is in the reverse, like denominator is numerator and numerator is denominator, then can we say it is 1 by e, the value?
Yeah, we can say it 1 by.
Okay, that's it.
Ma'am, we can do it with different ways. Like the first root under n factorial, we can convert into 1 by e and e कट गया तो फिर बहुत तरीके से बन सकता है मैम ये मैंने दूसरे तरीके से बनाया है।
हाँ करेक्ट देयर आर सो मेनी वेज व्हाटएवर यू प्रेफर ऐसे जरूरी नहीं है कि इसी सीक्वेंस में जाना चाहिए व्हाटएवर यू टाइप फर्स्ट डू द चेंजेस एंड सॉल्व it depends to person whatever he wants but the answer should be 5. Okay, so let's go to the next and last question.
Hello, ma'am.
Yes, Shweta.
Ma'am, please go above the same discussion. Someone is saying that if we are taking x factor, that inverse of 1 by e, that is something. So in that case, limit will not change?
No, so actually what he says, what will be this limit? Limit x going to infinity, this x root of x factorial upon x. So this is same as limit x going to infinity of 1 upon x upon x root of this thing, right? And we can distribute limit over numerator and denominator. So in the numerator, we have 1, which is constant. So it will remain as it is. And here, if you apply the limit, it will become limit x goes to infinity, x upon the x root of x factorial. And this is equal to 1 by e. So limit will change, but it will be equal to 1 by e in place of.
Okay, ma'am. Thank you.
Ma'am, I'm having a query.
Yeah.
Ma'am, what would be the value of log of 1 plus x by x at infinity, ma'am? Like if x tends to infinity, if we change it.
Then it will be equal to 0. Because then infinity by infinity form, you can apply L'Hospital rule. And as you said, that limit you computed, that it will be equal to 0. So yeah, correct. It is equal to 0.
It is equal to 0 only, right? Okay.
Okay, so let's go to this question, last one. So I'll give you just 4 minutes. I guess it's not that tough. So try to read it and solve it. So I'll give you 5 minutes. Let's take it to be 5 minutes. Please answer in the chat box and try to answer. At least try to guess. If you are not sure, just try to make a rough guess. If you are having any difficulty there.
Hello, ma'am.
At least answer. Yes.
I have a doubt regarding admission. I have paid the fees on November 6th, but yet I have not got any official mail ID and ID card for which I have to submit statistics weekly activity, and I can't submit that.
Okay, so can you give me your email ID? Whatever email ID you have given to supporting, because I'll go and check with them.
Yes, ma'am, I can do.
Yeah,
Where
just
to give?
put it into chat box.
Okay, ma'am. And do I
I'll
have
try
to
to
put the
talk with
password
them.
also?
No, don't need a password. Just mention your email ID. They can open your. Yeah, one thing you can do, you can mention your full name, whatever name you given there, and email ID, whatever you have given there.
Okay.
Okay, name and email. And we can look at your profile.
Is it okay? I have given. Please check it once.
No, actually, I haven't get. Please, I mean, I think you are sending to someone else, maybe. Send it to co-host, or my name is there. Send it to that, because I'm not getting your name or email. Now I get. So have you tried to reach out to the support team?
Yes, they told that please mention your problem in the live session. I have the mail that tells that.
Because we cannot actually do anything about it because this is a technical thing that they will handle all. Okay, I'll check with them. This is also an MSQ. There will be more than one option. Check it. But what we can do in as a course instructor, we don't have any access to, access your profile or see what is happening there. And although it's not our specialty, I also don't know what to do in this case. I'll talk to Vishal sir and let you know. Okay.
Okay, ma'am.
What is the issue?
Thank you, ma'am.
So, shall we discuss this or you guys want to do that? I have only one answer so far.
Ma'am, I'm stuck over that log part 1. A log of 1 plus x by x extends to 0, right? You have asked us to convert it to infinity form, like for infinity. So what did I do? I just explained to get 0. What did I do is I just changed the x value to, no. I just changed the limit of x tends to infinity and I did the same thing. Log of,
Okay.
log of
So you
1
haven't
plus.
changed here.
Yes, ma'am.
So here also
Then
you have to change.
if I do L hospital, then I did 1 plus 1 by 1 by 1 plus x.
Correct. So it will become 1 upon 1 plus x, it will become 0. But since you are changing this limit x going to 0, 2x going to infinity, so you have to do some substitution. So what you are making here, you're actually making x is equals to 1 by n. Then only if x goes to 0, n goes to infinity situation happen. When this limit and this limit are totally different, you are considering the same function, but the limit is different. So that's why you are getting 0.
Ma'am, did I do this correct differentiation for 1 by x? Like, can we or is it should be x power
No, your
minus 1?
differentiation is correct. Your differentiation is correct. It will be equal to 1 upon 1 plus x, and this x will become 1. So ultimately it will become 1 upon 1 plus x. So all steps are clear, but since you are jumping from limit x going to 0 to x going to infinity with the same function, that's the thing here. As you change your limit, you have to make some changes in your function too.
Okay.
So this is the thing. Limit x goes to 0, log of 1 plus x upon x. And this is the thing you have. Limit x going to infinity, log of 1 plus x upon x. So these two things are obviously not equal because function is same, but the limit are different.
Okay. Then if we make it into 1 by x, then the value
Then it
will
will
be
be same.
tending to 1 only, right?
Then the value will turn 10 to 1, and then only these limit are same. That means this limit upon x, this is same as limit x going to infinity of this function, log of 1 plus 1 by x upon x. So here we are changing the limit, but simultaneously we are making some changes in function in such a way that the sense of limit will become, it will be preserved.
Okay, ma'am. Okay. Now here it will be 1. The above one,
now here it will be
I
1.
thought in that way. Okay.
Okay. Okay, so let's try to solve this question. So here 3 sequences are given to us, and they are calculating some error in algorithms, and we want to judge what will be the efficient algorithm, right? So here error estimated by algorithm 1 is given by this sequence, error estimated by algorithm 2, error estimated by algorithm 3. So what we can do, we can find out the limit of the sequences and try to found one maximum kind of error, right? Because as n goes to infinity, if you find an where it goes, then that will be your maximum error because these sequences are giving us error, right? So it's given that suppose a company runs 3 algorithms to estimate the future growth. Suppose the error is estimated by error in estimation depends on the available number n of the data as follows over these 3 algorithms and these 3 sequences. So where n belongs to natural number minus 0. Suppose the company has a large amount of data in hands, so we can assume that n goes to infinity. So using the information given above, answer the question. So the first question says that error in estimation by algorithm 1 will give the maximum error. So for that, what we have to do, we have to first calculate the limit of all these 3 sequences and try to find out what will be the error will happen in these 3 sequences if we have large amount of data. Large amount of data means n goes to infinity type of situation. Okay, so here the sequence is n square plus 5n upon 6 n square plus 1, and we know that whenever we have such kind of sequence, what we do, we pull out the highest power of n, cancel it out, and then apply the limit. Because we know that limit n goes to infinity, 1 by n is equals to 0, right? So we just use this limit to solve what will be the limit of it. So limit n goes to infinity, an, this is same as limit n goes to infinity. I pull out the highest power, that is n square, so it will become n square. Here it will become 1 plus 5 by n. Because n is there, if I want to pull out n square, I have to multiply and divide by n. So then only n square will become in numerator. So denominator n will remain as it is. Okay. Now same thing I'll do in the denominator also. So it will become n square 6 plus 1 by n square. So here n square get cancelled out. And now we can distribute our limit over these two brackets. So it will become 1 plus limit n goes to infinity 5 by n upon 6 plus limit n goes to infinity 1 by n square. So it will become, this limit will become 0, this limit also becomes 0. So answer will be 1 by 6, right? So we can convert into decimal places. So it will become 0.7 something, whatever this is. 0.16, 1.66. So that's how we solve for the, that will be the error estimation for algorithm 1. The same thing we do for finding out the limit of second sequence, but second sequence is comparatively very easy. This is constant term, so we know that it will remain as it is. And it is a sequence given in form of 1 by n. And we know as n goes to infinity, 1 by n goes to 0. So that's why the limit of sequence Vn will become 1 by 8, and 1 by 8 is 0.12. Now, same thing we do for error estimation in the third algorithm. So here the function is given in form of e to the power n, and we know that limit n goes to infinity, e to the power n is equals to infinity, but limit n goes to infinity, 1 by e to the power n goes to 0, right? So we try to use of, we try to convert, we multiply and divide by e to the power n, so that we'll get 1 by e to the power n, as we do for the largest power of n, right? Here we pull out n square, so same thing we do for e. Here we pull off e to the power n. So if you take common e to the power n from numerator denominator, what it will be? So it will be equal to e to the power n bracket of 1 plus 4 by e to the power n, and then in the denominator is 7 by e to the power. So e to the power n into the power n will get cancelled out. We have this term, and here if we apply the limit, 1 remain as it is because it is a constant. Similarly, 7 remain as it is because it is a constant, and this limit will goes to 0 because it is 1 by e to the power n kind of limit. So it will go to 0. So the answer will be 1 by 7, approximately 0.1. Yeah, 0.142. So these are the errors. So that means first algorithm making error 0.166, second is 0.125, and third one is 0.14. So what will be the algorithm which is giving us a maximum error? So it will be the algorithm number 1. Okay, so that's why the first option is correct. So error estimation by algorithm 1 will give the maximum error. Error estimation by algorithm 3 will give us a maximum error. This option is correct. Both algorithm 1 and algorithm 2 will give the same error, and that will be the maximum. That's also incorrect. Error in estimation by algorithm 1 is 0.16. That's we already calculated, and this is also correct. So that's why the correct options are 1, 4, and 5. Okay. Any doubt in this question?
Why maximum, ma'am? For 1 it is 0.125.
Means?
Oh, sorry.
Maximum error.
Oh, no. Okay.
Yeah, so this is the answers. So correct one. Okay, so that's all I have. These many questions.
Ma'am,
if you guys have any
once
doubt,
could you go down? Yeah, I just have one doubt. Yeah, no, a bit up. I just forgot. A bit up, ma'am. 1 minute. I just forgot.
Ma'am, hello.
Okay, so
yes, ma'am. Can we do? I did L hospital for first algorithm. But for doing once of L hospital, I couldn't get the answer. I did it twice. Can we do it twice?
Yeah, we can do it. Yeah, you can do it twice, thrice.
Okay, ma'am.
Anytime you can.
That was my
until
okay.
and unless we have 0 by 0 or infinity by infinity.
Okay. Even
So,
1 by infinity is not is not a rule, right, ma'am? For L
No,
hospital.
no, 1 by infinity. We strictly follow 0 by 0 or infinity by infinity.
Okay.
Yeah, someone else was saying something. Please go
ma'am,
ahead.
so from week 8, we will start from the continuity portion.
Continuity portion. So continuity and differentiability is nothing but a special type of limit. So in continuity, what happens? Limit will be equal to value of function. So if this happens, we say function is continuous. And differentiability is nothing but a specific limit of a quotient function. So in place of f, you will have some quotient. That quotient is given by f of x minus f of a by x minus a. So if you compute the limit of this quotient, that limit actually defines the differentiability. So the limit is, you can say, the foundation of for continuity and differentiability. These two are nothing but some special kind of limits you have to judge. Any doubt from week 7? Anything you guys want to discuss? We have 10 minutes. Otherwise, you can drop. That's all from my side, and thank you for joining. I'll share the
Ma'am,
PDF.
7.4 in activity question.
Okay. 7.4, which question?
1 second. Sixth question.
Sixth one. This one? So let A and B a sequence converging
Yes,
to
ma'am.
limit 1. So here you have to use the concept of subsequences. Have you know what is the subsequences? So suppose you have a sequence here. So the sequence is nothing. I mean, we can list out by terms, right? So it will be A0, A1, A2, A3, and so on. So I'll give you the informal definition of subsequence. The formal definition involves a little much more. So informally, what a subsequence is, so what you do, you just pick out some terms from your sequence in the increasing order. Increasing order means if you, that means you are extracting one sub part of this sequence that is known to be subsequence. So suppose I'll take first term E0, and the second term to be my A3, and the third term to be my A7, and the fourth term to be and so on. But here one constraint is you cannot repeat a term, and you cannot you cannot you cannot take a term which is lesser than the previous one. That means A3, if I take here, I have to take, I can select all the terms which is in front of A3. That means I can select A4, A5, A6, but I cannot select A2 here, right? So this type of extraction is known to be a subsequence, right? So subsequence is nothing but listing out some element from our sequence. It could be any element. It could follow the same pattern, or it could, you can list out A0, A2, A4, A3, and so on. That will be one subsequence. This is one subsequence. So you have to list out some element from our sequence in such a way that first thing is you should not repeat a term. And the second thing is you should not repeat a term means if the value are same, then you can repeat, but terms should not repeat it. I mean, if A3 is there, then I cannot take A3 twice, right? And the second thing is you have to always take terms in the increasing order. So that's the subsequence. So here what is given to us, that we have a sequence and there is one result. So what is the result? So result says that if an converges to a limit A, then all its subsequences, subsequence converges to A. So that means if an converges to A, then all its subsequence will converges to A. So here it's given that A3n. So here 3 is written in the subscript. So A3n is there. So if you consider this sequence, so A3n is nothing but A0, A3, A6, A9, and so on, right? So this is nothing but a subsequence of this particular sequence here. And it's given that an is converging to 1. So that means any subsequent will converge to 1. So that's why this limit will be equal to 1. So it will implies a of 3n converges to 1. Okay.
Yes, ma'am. Yes, ma'am. Understood, ma'am. Okay. I thought it is 3 times a, so I just multiplied 3. Now I got it.
Yeah.
Now I got it.
Okay.
Multiples of 3. Okay. Yes. Thank you, ma'am.
Okay. Anything else? Any other doubt? I'll
Ma'am,
share this
7.
PDF. 7. Yes.
7.1 question number 11.
Okay. So here
So
function is given, so consider.
Yes, how will the graph look like x plus 1 by x?
Actually, we cannot say. I mean, by just looking the function, we cannot say, but you can use Desmos for that, right? So we'll find
What?
Desmos. You know,
Okay.
Desmos graphical calculus. Because this is not a simple graph, it's the addition of two functions. So addition of two function, this graph can look very strange. So y is equals to x plus 1 by x is the graph. So this is the graph. Looks like something like
Okay.
this. Right?
Okay.
Yeah, wherever you need a graph of some function, you can use this Desmos to find it out, right?
Thank you, ma'am.
Any other doubt? Okay.
Ma'am, where we can find the session PDF?
In the calendar, I'll post there one link, notes link, and then you can download it. Because if I paste in chat box, then some people will get some notification. So, or
Okay.
you guys can stay for
Uh,
1 minute and
Please
just
paste it
what
tomorrow
will.
because 15 is the deadline. Okay? We have to revise.
Okay. Yeah, yeah. Or else I can paste it now and you guys can check. It is
Okay, you
accessible
can
or not.
paste it now. No problem. It will be more helpful. Ma'am, your next session?
I think my next session is of maybe week 8 or 9 or a revision session I'll take. Because I have more, I mean, I'm not the main instructor, you know, so I'll take one session in week 8 maybe. It's possible.
Week 8 on Saturday. I think.
Maybe I'll take.
Okay, ma'am. Thanks for the session.
Yeah, thank you guys for joining. Can drop.
Ma'am, if you can take more sessions, then take because your approach of solving problem is good.
Yeah, I'll try. But I'll take revision sessions. Maybe.
Okay. Good night. Good night, ma'am. Bye.
Good night. Thank you guys for joining.
Thank you.
Yeah, can you guys wait for 1 minute? I'll paste it over the calendar and paste the link over calendar so someone can check is it accessible or not. I cannot paste here. Yes. Okay, I have to give to someone else who have access the calendar. I'll just give you guys the file, I mean the notes in the chat box. So is there someone is here? Sridhar, can you check to your calendar? The link of notes is available on. Hello? Anyone is here? Shweta, Prateek?
Yes, ma'am.
Yeah, can you please check on your calendar, is there notes link is accessible or not?
Yes, Amiksha. Sorry, I didn't put my microphone. I mean headphone. Yeah,
Okay.
we
Yes, ma'am.
In the calendar, accessible, na? Okay, that's
yeah, it's accessible. I was able to download it.
Thank you.
Thank you so much. Good night.
Okay, bye.
Bye, ma'am. Thank you, ma'am.